One of the things that we're going to want to do with vectors is to add them together. So we can do this a few different ways. One way is through what is called graphical representation. The idea is that we can visualize this very nicely. So let's say that we have two displacement vectors. So the idea is that we walk to the north and to the east here, so with this vector A, and then we walk to the south and the east like this with vector B. So we would like to know what our total displacement is. Well, one way we can do that is to take the head-to-tail method. So what we do is to add them together to find the total displacement after the both parts of the walk. So that means if we go from the tail of B lines up with the head of A, so essentially it's really just what happens in our walk, right? We walk up and to the east, then we walk south and to the east again, and so then that means that the C vector, so from the tail of A to the head of B, this corresponds to the displacement vector, so the sum of our A vector plus our B vector. So remember, we can move our vector around if we keep the angle and length the same. So that means we can move it and we can put it tail to tail like we do here. So here the tails of the vectors are lined up. So I don't know if this was like a force. It's kind of nice to see, all right, well, if you're pushing up this way, pushing this way, then that means the resultant force is going to be somewhere in between the two. So in some cases, that may be a more convenient way of visualizing it. Although since we haven't really talked about forces yet, we should maybe be a bit careful with that. Also, we may want to be able to subtract vectors. So to do that, we can do this a few ways. But first of all, if we want a negative vector, what happens is we can turn it around and turn it around 180 degrees so it is pointing in the opposite direction. So we take our B vector, then we turn it around 180 degrees, and that is what is our negative B vector. So the idea is that basically A minus B is the same thing as A plus negative B. So that means that we're going to add head to tail our A vector, so same one as we just did, and then our negative B vector, which is the B vector from before, that's flipped around 180 degrees. And so that means that from the tail of A to the head of negative B, so this then gives us our new vector. So also another way we can do this is that we can do our tail-to-tail method. And so if we think about this, if C is equal to A minus B, then we can add B to both sides, and that means B plus C is equal to A. So that means if we put our two vectors, our A and B vectors tail to tail, that means then B plus C gives us A, so that means the vector from the head of B to the head of A is then this C vector that we're looking for. So that corresponds to A minus B. Notice these two vectors here, they're exactly the same, so this works. So here's some examples of vector subtraction. So what is the change in velocity? So the change in velocity is the final velocity minus the initial velocity. So we can rearrange this and make the initial velocity plus the change in velocity is equal to the final velocity, right? Kind of what we just did. And so that means then we can write it like this. So here we have our initial velocity, here we have our final velocity, so A plus B is equal to C. And so, this is something we're going to want to be able to do, because if we want to know the change in velocity, if we want to know acceleration, then we're going to often need that change in velocity. So that means that we go from the head of the initial to the tail of the final. That gives us the delta, the change in velocity. So if we're doing this in 2 dimensions, so we have our initial velocity that's going down to the right, and our final velocity that's going up to the right. So then if we want to solve this, we can do it the same way we just did. So we can draw our initial velocity and final velocity, and we know that if we rearrange this, initial plus delta v gives us final. So if we go from the head of the initial velocity to the head of the final velocity, that gives us our change in the velocity. So yeah, and so this is useful because the acceleration vector is going to be in the direction of that change in the velocity. So this tells us the direction of the acceleration vector. So remember, the acceleration is the change in velocity, and velocity is a vector, so acceleration is also going to be a vector. So in general, we're probably going to be doing this mathematically, but I do think it's good to spend a little bit of time doing this graphically, because I think it's kind of easier to visualize when we do it this way, and we sort of see what we're doing when we do the math on it. So hopefully this helps a bit. All right, so you have a question to do, so good luck with that. I think I will stop here for the day. Remember, part of the reason I'm not going too fast here is that trig stuff that we did earlier, that tends to give people a good bit of trouble. So, I'll try and do a whole bunch of those in the online Zoom, so we have plenty of practice with it, because that's really one of those things that trips people up quite a bit. All right, so I guess good luck with your questions, and take care of yourself.